This is the 9th lecture in the review before we start diving into Algebra I. This topic is going to briefly cover greatest common factor, otherwise known as the GCF, and the least common multiple, LCM. Okay, let's start with greatest common factor. The greatest common factor of two or more numbers is the greatest number that is divisible by each of the numbers. The greatest common factor of two or more numbers is the greatest number that is divisible by each of the numbers, or the greatest factor that they have in common. So let's look at an example. Let's find the greatest common factor, and sometimes it's written like this: GCF 3645. That means find the greatest common factor of 36 and 45. A calculator often takes commands like this. So we want to find the greatest number that divides evenly into both 36 and 45. And to do that, we're going to find all the factors. We're going to do it the long way first so we can explain it. All the factors of 36 and all the factors of 45. Okay. All right. 36 is divisible by 1 and 36. 2 and 18. 3 and 12. 4 times 9, and it is not divisible by 5 because it doesn't end in a 5, but it is divisible by 6. It's 6 squared, and then it starts to repeat. So these are all the factors: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors of 36. All right, let's do the same thing for 45. We have 1 and 45. 45 is not even, so it's not divisible by 2. It is divisible by 3 because the sum of the digits is 9. 45 is 3 times 15. It's not divisible by 4. It is divisible by 5. It's 5 times 9. It's not divisible by 6. It's not divisible by 7. And it's not divisible by 8. So we're back to 9. So these are all the factors of 45. So the greatest common factor is going to be the largest number of these factors, and that is going to be 9. Okay. Now, if we're going to find the greatest common factor of some larger numbers, this might be a little tedious process. So there's a quicker way using prime factorizations. So we're going to fit the prime factorization method. Okay, so the first step is to find each prime factorization. Okay, let's do that. Let's do that up here. 36 is 6 times 6, and 6 is 2 times 3. So 36, let me see. 36, let's write that right here. 36 is 2 times 2 times 3 times 3. Now 45 is 9 times 5, and 9 is 3 times 3. So 45 is 3 times 3 times 5. So now what we're going to do is circle the common factors, the common primes. So there's 3 and a 3 and a 3 and a 3. And sure enough, 3 times 3 is 9. So the greatest common factor is 9. Multiply each and one of the factors. The result is the GCF. Okay, let's look at some more examples. Let's look at one with 3. Let's find the greatest common factor of 20, 45, since we'll do one we already did, so I'm not trying to teach and 110. Okay. 40, 30, 25, or 20, 45, and 110. Okay, so first we're going to find all the prime factorizations. 20 is 5 times 4, and 4 times 4 is 2, 4 is 2 times 2. So there's 20. 45 we already did, but I'll do it again. It's 9 times 5, and 3 times 3. And 110 is 11 times 10, and 10 is 2 times 5. Okay, so let's write these out. 20 is 2 times 2 times 5. 45 is 3 times 3 times 5. And 110 is 2 times 5 times 11. So there isn't a 2 in all of these, so you can just kind of cross the 2's off. There isn't a 3 in all of these, so you can cross the 3's out. There isn't an 11 in all of those. So what's left is the greatest common factor. So the greatest common factor of 20, 45, and 110 is 5. Okay, so that's the greatest common factor. The next thing that we're going to look at is the least common multiple. And it explains exactly what it is. If you know what a multiple is, then you know what the least common multiple is. It's the least common multiple of 2 or more numbers. Okay, so let me further example. Let's find the least common multiple of 2 and 3. Okay, so first we need to find multiples of 2 and 3. So the multiples of 2 are 2, 4, 6, 8, 10, 12. That's probably enough, huh? And the multiples of 3 are 3, 6, 9, 12, and so on. We'll put ... just to make sure. And the least common multiple of 2 and 3 is 6. So the least common multiple of 2 and 3 is 6. Because it's the smallest multiple that they both have in common. That's what we're trying to find out here. All right, so if we try to find the least common multiple of 20, 45, and 110, we're going to be counting for a while, unless we use the prime factorization method. And I already have the prime factors right here. So, this is 110, I'm sorry. So let's show you the prime factorization method. So we got 20 is equal to 2 times 2 times 5. 45 is equal to 3 times 3 times 5. And 110 is 2 times 5 times 11. Okay, so the first step is to find the prime factorizations. That's the easy part. There's 2 ways to do this. One involves a little harder dividing. I want to go over both methods just so that we're all clear on how to do this. So we're going to do the prime factorization first, and then I'll show you the other method. So we're going to find the prime factorizations. We just did that. 2, we're going to find each factor where they are used the most in each factorization. Find where they are used the most. So 2 is used twice here. It's not used at all there, and it's not used at all there. So we're going to use 2 2's. So the LCM is 2 squared. And 3 is used the most twice there. So that's times 3 squared. And then 5 is used once in each of them. And 11 is used once. So it's always a good idea kind of to cross out the ones that you already did so you don't count them twice. So the least common multiple is 2 times 2 times 3 times 3 times 5 times 11. Okay, that sounds like a lot of math, but I think we can kind of take this a little easier. 2 times 5 is 10. So we got 10 times 9 times 2 times 11. So now we have 110, which is 10 times 11, times 18. So let's see, 18 times 11 is 18, and 18 is 198. So this is 1980. We would have had to count out for a while if we were going to find the least common multiple of these three numbers. Okay. The other way to do that, we're going to get the same result. The other way is called the divide by primes method. You can use either method you want as long as you get the right answer. So we're going to write each of these out here, 20, 45, and 110. And we're going to divide each of these by all the prime numbers where they have in common. And we all know there's only one that they have in common because we already figured that out. And that's 5. So if we divide the 5 out, we're left with 4. And here we're left with 9. And here, what's 110 divided by 5? It's 22. So if we multiply 4 times 9 times 22 times 5, we do not get 1980. Okay, well, there's a common in both of these, 2. So we can divide that out. Okay. And what's left is going to be our answer. 11 times 9 times 2 times 2 times 5. So you divide, if there's more than one common prime in each of those, you just divide it out. And then what's left you multiply across the bottom and across the top. So we're going to multiply 2 times 2 times 3 times 3 times 5 times 11, which is what we just did right here. And we get 1980. It's the same thing. Let me do an example with some smaller numbers on that division so we can see what we're doing here. Let's find the LCM, and we'll do both ways. Find the LCM of 20 and 50. And you should know that that's 100, okay? Without doing this method. I'm just doing this method so we can see it the long way. And the answer is 100 because 20, 40, 60, 80, 100, and then 50, 100. But we're doing it the long way so that we can learn the process. Okay, so 20 is 4 times 5, and that's 2 times 2. And then 50 is 25 times 2, and it's 5 times 5. So what we have here is 20 is 2 times 2 times 5, and 50 is 2 times 5 times 5. Okay, so here's our common. This 2's used the most here, and it's used the most there. All right, and 2 times 2 is 4, and 5 times 5 is 25. 4 times 25 is 100, so that LCM is 100. Now let's do it this way, 20 and 50. If we divide, the first prime number is 2, we can divide both of them by, that's 10, and that's 50, 25, yep. And then they're both divisible by 5, and what's left there is 2 and 5, and that's all we can divide, so it's 5 times 2 times 5 times 2, which is 100. Let's look at another example. Let's find the LCM of 72 and 81. Okay, 72 is 8 times 9. and 8 is 2 times 4, and 9 is 2 times 2. So 72 is 2 times 2 times 2 times 3 times 3. And then 81 is 9 times 9, and 9 is 3 times 3 times 3 times 3. Okay, so we can see now that 2 is used the most here, and 3 is used the most here. So the LCM is 2 times 2 times 2 times 2, which is 8, and this is 81 because it's already multiplied. And 8 times 81 is 648. So the LCM of 72 and 81 is 648. Now, if you like the divide by primes method, we can try that one too. I like this method, but you can use either one. All right. So the primes that they're all have in common, are 3. They're both divisible by 3. They're not both even, so we have to start with 3. So if we divide a 3 out, 3 times 72 is what? It's 24. And 3 times 81 is 3 times what is 81? That's 27. And both of these are divisible by 3 as well. 24 divided by 3 is 8. And 27 divided by 3 is 9. So what's left is to multiply. There's nothing in common here. These are called coprime. So it's 9 times 8, which is 72, times 9. 72 times 9 is 648. Okay, let's try one with 3. Oh, let's try one with 4. Let's go off the brink and do GCF and LCM. So if you find the GCF, you're going to use the prime factorization tree anyway, and it's just a whole lot easier. Find the GCF and the LCM. And here's the numbers we're going to do. We're going to do 12, 20, 70, and 98. 12, 20, 70, and 98. Okay. So 12 is what? Let's do these trees over here. 12 is 3 times 4, and 4 is 2 times 2. So this is 2 times 2 times 3 times, that's it. 20 we already did on the other page. It's 4 times 5. So I'm not going to do it again. 70, I'll just write it over here. 70 is 7 times 10, and that's 2 times 5. So that's going to be 70 is 2 times 5 times 7. And 98 is 49 times 2. Because it's even. You start with the 2. And 49 is 7 squared. So 98 is 2 times 7 times 7. So there is a greatest common factor, of course, it's 2. It's the only one that's in all 3 of them. So the greatest common factor of 12, 20, 70, and 98 is 2. Okay, now to find the LCM. And we'll find it both ways. Okay, let's do it the easy way first, so I can guarantee that this is a little bit easier to do it. 2 is used the most here. It's also used twice there, but you only do it once. So it's going to be, the LCM is 2 times 2, and let's X off all the 2s so we don't get confused here. 3 is used the most once there, and there's no other 3s. 5 is used the most once there, and 7 is used the most twice. Okay. So how are we going to do this? Multiply these. Well, the easiest thing to do is do that first. Let's circle the numbers that we can multiply easily. Actually, yeah, that's 10. So the LCM is 10 times 6 times 49. Okay, because this is 6 and this is 49. So 10 times 6 times 49 is 49 times 60. And 49 times 60 is 2940. So that would be when you're going to learn that we're doing this so we can add fractions. There's other things we use it for. For example, if these cars were running around a lap and one was going 12 miles an hour and one was going 20 miles an hour and one was going 70 miles an hour and one was going 98 miles an hour, how many times would they cross? How many times would they all cross if they all started at the same time? And that would be every this many. That's another reason to use the LCM. Not that it's going to come up more in fractions, but that's just an application of the least common multiple. Okay, so let's try it the other way. And I'm just going to get to where we multiply the numbers we multiply. I'm not going to multiply them again. All right, we already know that they all have 2's in them. So this is a 6, this is a 10, this is a 35, and this is a 49. Okay. And these have 2's in them. So this is going to be a 3, and this is going to be a 5, and these are going to stay alone because we can't divide them. And both of these have a 5 in them. So that's going to be a 1, and this is going to be a 7, and this is going to be a 3, and this is going to be a 3. Oh, 49, I'm sorry. And then both of these are common here. So this is going to be a 1, and this is going to be a 7, 1, 3. So what we're going to multiply, oh, and this is a 7, I'm sorry. This is a 7 times 1 times 1. Okay, so 7 times 7, there's your 7 squared, times 5, times 3, times 2 times 2. So you could do it either way. There's more steps of division here. Oh, that's off the screen. I'm sorry. Let me do that again just so you can see what we did. All right, so we had this across here. We divided through by 2. 12 divided by 2 is 6. 20 divided by 2 is 10. 70 divided by 2 is 35. 98 divided by 2 is 49. Okay, then we looked at this row, and both of these are divisible by 2. So we divide this by 2 and get 3. Divide this by 2 and get 5. These can't be divided by 2, so they just come down. And then we looked at 5, because both of these have 5 in common. So we can't divide there, but 5 divided by 5 is 1. 35 divided by 5 is 7. 45 can't be divided, so it comes down. Now both of these have a 7 in them. 7 divided by 7 is 1. 49 divided by 7 is 7. So what's across the bottom and up the side is what we multiply together. So we have 2, and it's the same thing we multiplied here before. 2 times 2 times 3 times 5 times 7 times 7. And that concludes the lecture on greatest common factor and least common multiple. The next lesson, quick really review, and this is supposed to be a review, that's why they're kind of quick. You should already know how to do this. Equivalent, I can't spell, equivalent, let me try that again. Equivalent fractions will be lesson 10. I look forward to seeing you there. Thanks for watching. Until then.